Let's look at this quiz. The first problem, evaluate the following logarithmic expressions and approximate your results. For this problem, we are going to use the change of base property of logarithm, which states that if you have an arbitrary logarithmic expression log a, x, a being the base, this equals to log b x over log b a, b being the same base on the numerator and the denominator. And for convenience, we normally would rewrite this into either the common logarithm with a base of 10, log x over log a, or the natural logarithm ln x over ln a. The reason is because we can easily evaluate the common logarithm and natural logarithm from our calculator. Either way will work as long as you are consistent, making sure that you have the same base on the numerator and the denominator. Therefore, the first problem, this equals to, I'm just going to use the common logarithm. Once again, if you use the natural logarithm, it will give you the same answer. So 27 log divided by 9 log, and this equals to 1.5. And then the second problem, very similar. We're going to have log 15 divided by log 0.3. That equals to approximately negative 2.249. And then again, we have log. For this one right here, you want to calculate 1 over 24 first, and then log divided by 4 log, and that equals to negative 2.292. And last one right here, do not let this e to the second power confuse you. It creates an impression that you should apply the inverse property, but this problem is not. If the problem is log e to the second power or ln e to the second power, yes, you can use the inverse property. You can evaluate this to be 2 directly without using a calculator. But notice here the base is 2. You should not use the inverse property, and we're just going to do the same thing. We evaluate e to the second power first, which is approximately 7.389, and then log divided by 2 log, which equals to 2.885. Or if you say, for this problem, can I use the natural logarithm instead? I will have ln e to the second power over ln 2. Therefore, I will have 2 over ln 2. That's fine. So you will have 2 divided by 2 ln, and as you can see, you will have the same answer. So it's important that you understand how to use the change of base property of logarithm. Next problem, completely expand the expression as a sum, difference, and or constant multiple of logarithms. So for this problem, we're going to apply the combination of the product property, the quotient property, and the power property. So very quickly, product property, if you have log a, the same base, u times v, that equals to log a u plus log a v. Quotient property, log a u divided by v, this equals to log a u minus log a v. Don't forget they have to have the same base. Lastly, power property, log a u to the nth power, this equals to, you can pull the n as a coefficient in front of the expression, and then log a u. Okay, so we're going to apply, first of all, we can apply the quotient property. So the original expression becomes ln y to the second power multiplied by z minus w to the third power, applying the quotient property minus ln square root of x plus 1. Don't forget, square root is in actually 1/2 power. Okay, and then for the first term, we can apply the product property ln y to the second power plus ln z, this is z, minus w to the third power minus ln x plus 1 to the 1/2 power. And then we can apply the power property, and we will have 2 multiplied by ln y plus 3 multiplied by ln z minus w, and then minus 1/2 times ln x plus 1. And pay attention to these. If you look at your product property and quotient property, you realize that these do not follow the product property or quotient property. Okay, therefore one of the very common mistakes that the students in the past would make is they will mistakenly apply, say, quotient property and say this term equals to ln z over w, and that will be incorrect, or ln z over ln w. Either way, that will be incorrect. So make sure you don't make that mistake. Next problem, solve the equation for x. When you look at this problem, you probably want to apply the one-to-one property. However, don't forget, when you apply one-to-one property, you must have, first of all, a single term on both sides, and secondly, you must have the same base. In this problem, you do have single term on both sides of the equation. However, you don't have the same base. You have 3, and then over on the right you have 9. Okay, you can only apply one-to-one property if a to the x1 power equals to a to the x2 power. Then the conclusion will be x1 equals to x2. So you cannot apply the one-to-one property yet, but if you do something about the right hand side, then you might be able to. Don't forget, 9 equals to 3 to the second power. So the right hand side equals to 3 to the second power to the x plus 1's power. And don't forget, if you have a to the b's power to the c's power, this equals to a to the b multiplied by c's power. Therefore, the right hand side becomes 3 to the 2 times x plus 1's power. And now the left hand side and right hand side, they have the same base. Therefore, according to the one-to-one property, x squared minus 1 equals to 2x plus 1. Therefore, this equals to 2x plus 2. Rearrange it, x squared minus 2x minus 3 equals to 0. Factor it, x minus 3. X plus 1 equals to 0. Therefore, x equals to 3, or x equals to negative 1. And you can double check to see if both of these two answers satisfy your original equation, and they should be. Okay, so that's this problem. Next one, for this problem, for this type of problem, notice that how e to the 2x power equals to e to the x power and then to the second power. Therefore, for this type of problem, we should notice the form, how it resembles the quadratic equation form, and we should just go ahead and apply our knowledge using factorizing, or apply the quadratic formula if you have to. So in this case, it's not that difficult to factor. So this becomes e to the x power to the second power minus 5ex plus 6 equals to 0. Therefore, we have e to the x's power minus 2 multiplied by e to the x power minus 3 equals to 0. From here, we can solve for e to the x power equals to 2, or e to the x power equals to 3. However, don't forget, your job, your task is to find x, not ex. Therefore, from here you can solve for x equals to ln 2. And from here you can also solve for x, so x equals to ln 3. Okay, if you want to evaluate it, ln 2 is approximately 0.691. ln 3 is approximately 1.099, and they are both valid solutions to this equation. Last problem. Again, when you look at this problem, if you want to apply the one-to-one property, you cannot. The reason is because even though in this equation, all logarithmic expression, they all have the same base. They are all of base of e. However, on the left-hand side, you don't have a single term. Therefore, you want to do something about it. You want the left-hand side to become a single term so that you can apply the one-to-one property. So on the left-hand side, we can use the product property, quotient property, and power property that we just reviewed earlier to, in this case, condense the entire left-hand side into one expression, right? So by applying that, we have ln x minus 2 multiplied by x minus 3 divided by x, and that equals to ln 2. Okay, don't forget, naturally x cannot be 0 because in this expression, right, the domain of the logarithm function is x has to be bigger than 0 anyway. So now we can get rid of the ln sign by applying the one-to-one property. Therefore, x minus 2, x minus 3 divided by x equals to 2. Rearrange this, we have x minus 2, x minus 3 equals to 2x, x squared minus 5x plus 6 equals to 2x, x squared minus 7x plus 6 equals to 0. Therefore, x minus 1, x minus 6 equals to 0, x equals to 1, and x equals to 6. However, when you have a logarithmic equation, you must double check to see if your solutions are valid, because don't forget, you have domain requirement for logarithm. Unlike exponential functions, for exponential functions, the domain is all real number. So in this case, if x equals to 6, then as you can see, here you will have ln4, ln3, and ln6. It's all valid. However, when x equals to 1, here you will have ln negative 1, ln negative 2, and that will not be correct. Therefore, this solution must be eliminated. So x equals to 6 is the only solution to this problem.